Hello, welcome. We are going to be doing 4-4 notes where we're proving triangles congruent with ASA and AAS. Yesterday you already did 2 other triangle congruences. Today we're going to introduce 2 more. This is page 64 in your note guide. So, again, a warm-up, pause, complete the warm-up on your own and then come back and check it. Remember, you're looking for the biggest perfect square. The biggest perfect square here is going to be 100 times 13. So our answer here is going to be 10 root 13. Again, I always put the perfect square in the first spot so I can take the square root and it's already in the first position. This one we're taking a square root. I always know because it's an invisible 2, I need all of my numbers to be divisible by 2. So I rewrite it. I'm going to say x to the 14th. Then I'm going to say x, so it's still x to the 15th. I still have enough x's. The next one, y to the 4th, is already even. Z to the 19th, the first even number underneath, is going to be 18. So I'm going to write z to the 18 times z. Okay, so because it is a square root, you're cutting your exponent in half. Half of 14, I'm going to get x to the 7th. Half of 4, I'm going to get y squared. Half of 18, I'm going to get z to the 9th. Those all come out of the radical. Staying underneath the radical, I have 1x and 1z. So pat on the back, those of you who could simplify that correctly, good job. Also, now the next ones, I highlight things that I want to kind of pay attention to. I want to look for perfect squares. I want to look for things that may be divisible. I could reduce 3 over 81. But 81 is a perfect square, so I kind of want to pay attention to that. Here, 48 and 3, I can reduce, so I want to do that. This one, you have none of those options, so we'll leave it alone for a minute. So here, I'm going to take square root of 3 over the square root of 81. The square root of 81 is 9, so the 9 comes out of the radical. You don't take a square root again, even though it is a perfect square, because it's not in the radical. So our answer is root 3 over 9. And sometimes we want to reduce still. You can't because one's under a radical and one's not. Here I have 48 divided by 3. I get square root of 16, which is a perfect square. So I'm going to go ahead and write 4 as my final answer. And there we go. So this right here is square root of 2 over square root of 13. Now the problem here is that we can't have a radical in the denominator. So what we have to do is rationalize the denominator. We rationalize by multiplying square root of 13 over square root of 13. Square root of 13 over square root of 13 is 1, so I'm not really changing the number, I'm just changing how it looks. So 2 times 13, I get square root of 26. Now on the bottom, 13 times 13 is 169, which is a perfect square of 13. So you can write that step, but you don't need to, because you're purposefully multiplying by itself to get rid of the radical. So again, these are going to keep showing up. Good luck. Come and ask questions if you're struggling with any of those. All right, so when I get to triangle congruences, I always tell my students that there are going to be 5 triangle congruences. Every time I come across them, I list the 5 in order, so I know that I know them all. So my 5 triangle congruences, I have 2 that you got in the last set of notes. The first triangle congruence is side, side, side. The second triangle congruence that I know is side, angle, side. The 2 that we're going to learn today are going to be angle, side, angle. And the next one is going to be angle, angle, side. There's one more and it comes up, I think, in section 4.6. So you're going to get one more triangle congruence in a couple of days. Okay, so side, angle, side here. I would draw kind of, angle, side, angle postulate. If 2 angles and the included side, so that's really important that it's the included side of a triangle are congruent to 2 angles in the included side of the second, then you know the triangles are going to be congruent. So the reason that is true is because let's say we have, let me get a straight edge so it's not messy. I'm going to have this side down. So if I have an angle right here that let's say was 20 degrees, and I knew this side, let's say 3 centimeters, and then this angle over here, so it's the angle, the side between the two angles, and the other angle. And I knew this angle over here, let's say was 40 degrees. The only way for these to intersect is to come right here and intersect at this spot, which is going to make every other side and every other angle congruent. It's going to force it to be congruent. So if you have angle, side, angle, another thing I do is I put the letters on there to help me see the pattern, because it is tricky, and there's 5 different combinations of letters we can have. It's really easy to mix them up. You have to make sure angle, side, angle, it's in order, and it's the included side. So you got to kind of be careful about that. Now over here, we have another one, angle, angle, side. Which means, let's say I have an angle here, and my angle is this measurement, this angle, and the next angle is an angle like this. Oh, I'm going to use my whiteout. My angle. So I have an angle here that I know of, another angle right next to it that I know of, and this side right here. So this time I have 2 angles and a non-included side. So that's really important. I'm going to use a different color actually. A non-included side. So if I have a non-included side right here, so it is not between the 2 angles, it's going to force the triangle to be congruent. It's going to force it to come right here. There's no other way you could create that triangle. Okay, I usually talk to my students in class about, okay, these are our 4. What other combinations might there be of triangle congruences? And I usually get students to say, one combination that we don't have here is AAA. And another combination we don't have here is, we're going to actually say SSA. We don't want to write that the other way because that's a bad word. And either way, these don't work. So I always remember that AAA does not work and the bad word does not work. I can show you why they don't work. Let's say I had an angle, angle, angle here. Well, all 3 of these were the exact same angle. And if they're all the exact same angle and it was 180 for all 3, each angle would then be 60 degrees. So, what if I had a larger triangle and I still had all 3 angles that were the same? It's still 60, 60, 60, but it's much larger. So even though all sides are the same here, they're not congruent to each other, so they do not create congruent triangles, angle, angle, angle. Also, my side angle, or the bad word, again, does not work. It does not work because of this. Let's say we have an angle here. Let's say we have a side here that we know. And let's say that our other side is this line right here. I know this angle, and I know this side and this side. Couldn't that side also go like this? Couldn't that same distance go this way? Isn't that the same length as that? So I can either have this little tiny triangle here, or I can have this much larger triangle here that would have the same side-side angle. And so what I call this, and what I've heard it called before, is that it's kind of like this swinging door. That if you have a triangle, and you could make a triangle this way or this way, this door could swing and create a triangle here or here. And either way, they're not going to be congruent. One would have an obtuse angle, one would have an acute one. So just be careful with that one. That doesn't work. So again, we have 4 today. We are going to learn a 5th one on, I don't remember, I think it's 4-6. Okay, so right here, is it possible to prove that these triangles are congruent? If so, state the postulate or theorem and write the triangle congruence. So I'm going to use some highlighters, blue and green right here. I'm going to say, alphabetically, I'm going to call this triangle, H starts first. So alphabetically, I'm going to name it H. What can I name alphabetically? It's going to be H-I-J. So H-I-J, I was supposed to highlight that, sorry. H-I-J. H starts at that first angle. What does it correspond to on the next triangle? It corresponds to J. So we're going to start with J, K, H. So that would be our triangle congruence. Does it work? Is it true? I have 2 angles, and is there any side that I know has to be the same? The side I know is this side that they share. This is where we use our reflexive property that HJ is part of this triangle and HJ is part of that triangle. So I know that I have a angle, side, angle. I have an angle, a side in between, and an angle. So this is angle, side, angle, congruence. Okay, now if it's hard to see here, my other suggestion is that maybe you want to draw the 2 triangles separately. And if I had K, J, H, and I had H, I, J, I know that this angle here is the same as this angle here. I know this angle here is the same as this angle here. And I know that they share this side right here. So sometimes if it's easier for me to see, I want to draw them separately, and then I can see, oh yeah, angle included side angle. And it's not being shared on both sides. So if you need to, go ahead and draw them separately. Over here, which letter comes first alphabetically? The letter I'm going to start with, I'm naming my triangle congruence, is going to be C. So I'm going to name this CDG. So CDG is congruent to, it starts with the 2. I'm going to have to start with F. CDG is going to be FDE. Now that would be my congruent statement if it's true. Now I have to just justify if it's true or not. I have 2 angles. Do I know any other sides or any other angles? Well, I do know that third angle. So if I know 2 angles, I know the third one has to be congruent because of my third angle theorem or because of vertical angles here. So I would say this is congruent to this because of my angle, angle, angle congruence. But I just talked about that at the top. Last year I drew the triangles right here. I would have drawn a triangle here to show the 3 angles, and then a bigger one where the angles are congruent, they're all 60, but this is not possible. So really you're going to tell me not congruent because that doesn't work. So this one would be not possible. I'm going to pause and go to the next page, and I will see you in just a minute. Okay, so we're going to go to this proof on the next page here, and a lot of it's already filled in for you, so hopefully we can fill in some of those steps. Now B is congruent to C, D is congruent to F, M is midpoint of DF, that's all given. So my second step here is if I know these things, first I'm going to label everything I know. B and C are the same, D and F are the same, M is the midpoint of DF. So what does that tell me? And I probably need to do that. I want to prove that these two triangles are congruent at the end, and I have two angles. So I have an angle here, and I have an angle here. How many triangle congruences do I have? Right now I have 4, and I'm going to know 5. So I have 2 angles in this one. 5 that I know I usually write down is side, 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 angle, side, angle, side, angle, and angle, angle, side. That's ugly, so I'm going to use my handy dandy whiteout. So I have 2 angles, which means I'm probably going to use either the third or the fourth one. Okay, so I need to figure out a side. 3 angles are not going to help me. I need to figure out a side, and I know that this is a midpoint. Well, that's the midpoint. That tells me that these have to be cut in half. That means that DM, line segment DM, is congruent to line segment FM, because that's my definition of a midpoint. Do I have enough information to say those triangles are now congruent? And yes, I do. So write which one you think it is. Angle, angle, side. It is not the included side between the angles. It is the non-included side. So this would be angle, angle, side, congruence. There we go. So now here I come to the next one. Angle A is congruent to angle P. Line segment MB is perpendicular to line segment AP. Immediately, I mentioned up here as well, but they were already marked. If you have information here, you want to label it on your diagram. So I know that A is congruent to P, and I know that this is perpendicular. So things that I can now say because of this, I can say if this is perpendicular, I know that these are right angles. I know that angle ABM, and I know angle PBM are right angles, because that's my definition of perpendicular. Now, once I know that they're right angles, now I know those 2 angles have to be congruent. Angle ABM is congruent to angle PBM, because that's all right angles are congruent. Now for me, I feel like this one is super redundant, and I understand, and it's kind of a pain with some of the proofs, but this is going to happen every time. If you know perpendicular, you know you have right angles, you know those right angles are congruent. Definition of perpendicular, all right angles are congruent. Similar to when we have the equal sign and the congruent symbol, whenever we take the same statement and we just change the signs, that's our definition of congruence. These are things that are just going to happen every time. And so you get used to it, it's a pattern, and when it happens, you recognize it, hopefully, and you can do that piece. I understand it seems redundant, but again, it's just going to happen every time. So now I have this angle and this angle. I have 2 angles that are congruent. I like to label it. Again, I have 2 angles. If I look back up here, I'm probably going to use my third or my fourth one. I need a side. Are there any sides that I can say are congruent in this problem? And when I look at the problem, they share this side, MB. Again, I mentioned earlier, this is where that reflexive property is going to come into play. When you share this property, I can say that BM is congruent to BM because it's itself. So I just told you the reason. It is like looking in a mirror. This is the reflexive property. of congruence. And so now I have angle, angle, side. This again, this side is not between the two angles. I'm going to use angle, angle, side congruence. Also, like I mentioned earlier, if you wanted to draw those as two separate triangles, that might be easier for you to see it, and that's always an option. Okay, after that, that's the end of like the notes for today. We're going to do review problems. So these reviews, you should pause and you should come back and watch the videos that way. I am going to work these out with you. So again, you can fast forward if you know you got them right. We're going to pause, write two equations this time. So if I'm going to write two equations for a line, and I know it passes through here, and it is perpendicular to this line. So I need to kind of pay attention to that. Two equations means I probably want to start with my point slope. Y minus equals m times x minus. I fill in my ghost formula. Y minus 4 is my y. X minus 3 is my x. Now my slope. Pay attention to this part. Remember, this needs to be isolated. It's not isolated, so I have to divide everything by 5. The slope of this line to begin with is going to be 3 over 5. Well, I don't want that slope. I want the perpendicular slope. So the perpendicular slope is going to be the opposite of that and the reciprocal, negative 5 thirds. So pat on the back if you got that one right. Good job. I always write it out every time just to make sure I go through the process and I think through the step, because it's so easy to mess that up and forget that, and I rush and I get in a hurry. It's easy to forget, so I always make sure I write it off to the side so I'm doing what they tell me to do, so I go through that step. So it said to write two equations. This is one, and if you just had to write one equation, you're done. Because I have to write two, now I'm going to solve for y and put it in slope-intercept form. So remember, this one up here is point slope. Now I'm going to solve for slope-intercept. Say y minus 4. Distribute this, I get negative 5 thirds x. Negative times negative is going to be a positive, and that 3 is going to cancel. I'm going to get a positive 5. Not done yet, the y is not isolated. I'm going to add 4 over here. So y equals negative 5 thirds x. Add 4 to give me a plus 9. So here are my two equations of a line. Remember that this one here is slope, point slope, point slope. And this one here is slope intercept. Okay, so remember that you have two different ones you can do. Okay, here we want to factor some problems. The first thing you kind of want to look for every time is if there is a GCF or a greatest common factor. I can factor out a 3x here first. Once I factor out a 3x, I'm left with 6x squared minus 17x plus 12. Now, don't forget that 3x. If you have an answer column somewhere, that is super easy to forget. So if you wanted to write it down on the answer right away, do that so you don't forget. It's easy to just forget about it, obviously. Okay, so here we have 6x and 6x. Now if you remember how we do these, this is obviously too much. 6 times 6 is 36. I have to remember that if I'm doing it this way, I'm going to need to divide by a 6 at some point. I do 6 times 12, I get 72. And I want factors of 72. The sign right here is a positive. If it ends in a positive, my factors are going to be the same as the middle. So they're both going to be negatives here. So they're going to be the same. Factors of 72 that add up to 17. You can list all of your factors. Hopefully we see that this one's going to be 8 and 9. Minus 8 minus 9. Okay, so is there anything I could divide out of this one? This one I could divide by 2. Anything I could divide out of this one? I could divide out of 3. So the reason why this is super nice, I usually do this in green notes because 2 times 3 is 6, which gets rid of that 1 6. So it has to get rid of that whole number, you did something wrong. So my final answer here, divide by 2, I get 3x minus 4. This one over here, I end up with 2x minus 3. Now you can always FOIL this back together, distribute the 3x back in, and you will end up with the same answer. So you can always go backwards and check, but there you go. Now, the next one, so again, GCF, and then second thing you want to do is keep factoring. In case you forgot something, keep factoring. This is one where there are 4 terms. Remember, if there are 4 terms, it is factor by grouping. So I'm going to factor by grouping. I'm going to group the first 2 together. I'm going to group the last 2 together. Factor out an x squared. Factor out a negative 9. There's a negative in the middle here. You need to factor out a negative number. Factor out the x squared. I have x squared times 2x, x squared times 1. Now this should match. I can go ahead and put the 2x plus 1 in here and go back and check. Negative 9 is 18. It works. Make sure they match. Now I'm going to have 2x plus 1. And my other factor is x squared minus 9. Can I go any farther? Well, this is quadratic. I can't do anything with the 2x plus 1, so I keep it here. But this x squared minus 9, hopefully you guys remember this from last year. This is technically a difference of 2 squares. You have x and x. It ends in a negative, which means your signs are going to be opposites. They're going to be different. You're going to have a plus and a minus. I have no middle term this time. So x squared and 9 are 2 different squares, 2 different perfect squares. There's a difference of perfect squares. Square root of 9 is 3, so if I have plus 3 and minus 3, I have no middle term. That's it, I'm done. You can FOIL that back together to check. Here we go. Difference of 2 squares. Okay, we have one more page because we're doing a lot of review problems, so this is going to go over the half-hour mark that I'm trying to shoot for. Again, pause, do everything you can on this back page, and then come back and check and see what you did, how well you did it. Okay, I'm going to pause and I'm going to fill in a few things before I come back. I'm going to show you little pieces at a time. Remember, I like to shade them in color code so I know how to set them up. If they're the same color, they are congruent. If they are different colors, they're going to be supplementary. Set up your equations and state the postulate, and I'm going to show you again in just a minute. I'm going to pause. Okay, so remember over here they're equal. Over here they were supplementary, add together to equal 180. X squared and x, I want to set it equal to 0, it's quadratic. These ones, I'm going to want to FOIL this together, or I know that we've done this before, we've done like a box method up in the corner. So you can do a box method or FOIL that together and then combine your like terms. This is how I set them up. 4x squared plus 2x minus 11 fourths, 6x squared plus 19x plus 10. And then I'm just going to add it right underneath it and set it equal to 180. I'm going to go ahead and pause and do the rest of the work. You should work through it. Oh, one thing more. Remember, usually you want to clear the fraction, but in this particular case, because that's your C, if you're going to plug this into quadratic formula, that 4 is just going to cancel out, so you don't have to multiply by 4 here. You can plug those numbers directly in. That doesn't happen very often, but it is important to kind of see and look at. I'm going to pause and fill the rest of it in. So I finished those problems. We also did these exact same problems in the notes, so hopefully some of you recognize them and were able to kind of work through them. It's really good practice, so do that. Again, if you have a question, highlight it or put a sticky note by it and ask in office hours. Thank you. We'll go on. I thought I had a student pop in. Okay, now we're going to graph these 3 lines, find area and perimeter of it. I'm going to go ahead and talk you through these. Pause, graph all of them that you can, if you can do that first. This one is in point slope form, so you want to pick out the point first. The point I'm going to start with here, opposite of x, so it's -3, it's going to be +3. Opposite of y, because it's +4, you're going to take a -4. I'm going to start at 3, -4. So I go 3, -4, we start right here. And my slope is going to be a +2/5. I go up 2 over 1, 2, 3, 4, 5 to create a positive line. I can go down 2 and back 1, 2, 3, 4, 5. Go down 2, back 1, 2, 3, 4, 5. You want to ensure that you have a positive slope. Graph as many points as you can so you can create that line. Okay, so that's our first line. The second one is x equals -2. These are nice because you know they're going to be horizontal or vertical. This one is vertical. X equals -2 is here, which means everywhere on that line is where x can equal -2. That line here. My last one is in standard form, so I like to use my cover-up method. I say if x is 0, what is y going to be? And if y is 0, what is x going to be? So if x is 0, y will be 2. If y is 0, 2x is 2, you would divide by 2, and x will equal 1. These are 2 points you plot. I'm going to go to 0, 2, and 1, 0. Now I can see this slope is down 2 over 1, down 2 over 1, down 2 over 1, up 2, back 1, up 2, back 1. I can kind of see it because it's pretty close, but I can also use, remember that your slope is -a over b. -a is going to be -2 over 1, which is 2 over 1. Again, I plot as many of them as I can, because I want to make a really good line. So here's my triangle. I have to find the area and perimeter. I think it's easier to do area first. Area of a triangle is equal to 1/2 the base times the height. Remember, I have a base here. I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My eyes are bad. I hope I can have it. Here's my height. It is 1, 2, 3, 4, 5. So my area here is going to be 1/2. My base is 12. My height is 5. Half of 12 is 6. Times 5 is going to be 30 units squared. Okay, so now I've created 2 triangles over here as well. Now I like to shade the 2 triangles so I can see what's going on. I have one big triangle, but you can use distance formula again to find the other sides. I find it easier to use Pythagorean theorem. So I like to look at them separately. I'm going to count one more time to make sure I did not mess up. I have 1, 2 here, which means I should have 1, 2, 3, 4, and 6. So that's going to be 10 here. So 10 by 5. So remember that 12 was for the whole length was the 12. All right. So perimeter is going to be 3 sides. One of the sides is 12. The other 2 sides I'm going to use Pythagorean theorem. So I'm going to say 5 squared plus 10 squared, 25 plus 100, 125. The square root of 125 is going to be 25 times 5. I'm going to get 5 root 5 for this one here. The next one is 5 by 2. So I'm going to say 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. 29. So you square root that, and I get root 29 for the next one. I can't simplify that. That is a prime number. And none of these are like terms either, so I can't add them together. So perimeter is just units at the end. So I'm going to classify the triangle. Classifying the triangle, none of the three sides are the same. So again, we have a scalene triangle. Now we have to decide if that's a right angle. It doesn't really look. It looks like it's a cube. You can always take a sticky note or some kind of corner of the paper and put it in here. And you see that that is definitely less than the 90-degree angle. So this is an acute triangle. An acute scalene or a scalene acute. There we go. Hopefully we did well on those. A lot of that was review. Again, come to office hours. We can go over any of those concepts with you. Have a fabulous day.